Thank you for coming to my talk. Today I'm going to talk about how to compare the performance of the various JavaScript frameworks using real-world data. But before we start, I'd like to ask you two questions. So first of all, please raise your hand if you enjoy and prefer using fast websites. Okay, great. Now keep your hand up if every website that you build always has good performance. Yeah, so why is it that, given that we all prefer using and creating fast websites, why is it that the websites that we ourselves build aren't always fast? And the answer is, this is not what is supposed to be shown. This is what's supposed to be shown. So the answer is that it's hard. It's hard building fast websites. And we know it's hard because, as we saw before, all of us don't always succeed. So what can we do to overcome this difficulty? That's going to be part of the topic of this talk. But before we go there, a few words about myself. My name is Dan Shappir. I'm the performance tech lead at Next Insurance, nothing to do with Next.js, just happens to be the similar name. We're an insurtech unicorn aiming to revolutionize the way in which small businesses get insurance, currently in the United States. And I'm the performance tech lead there precisely because it's so difficult creating fast websites that they had to bring me on board to help them deal with that problem. I'm also an invited expert on the W3C Web Performance Working Group, where a lot of the standards around performance that we'll be talking about get discussed and standardized. I'm also a host on the popular JavaScript Jabber podcast, where we've had some great guests like Ryan over here and Dan Abramov recently, and many others. I highly recommend listening to it. And in general, I really love the open web, and I've been doing it for a long time. And again, especially focusing on performance. This is my Twitter handle. Feel free to follow me. I tweet about web development and web performance. So going back to our original issue of why it's so difficult to create fast websites, and a lot of it has to do with the tools that we use. We want to use the best tools for the job, and that means using the tools that provide us with the best developer experience, for example, but it also means the tools that set us up for performance success and maybe try to avoid tools that set us up for performance failure. And probably the most important tool that we use is the framework that we use. Because really, if you think about it, it's the framework that's the driver of our web application. And it's our code that's sitting there in the back telling the framework where we want to go, and hopefully the framework takes us there. Because if you think about it, the framework decides when to invoke our code, what to use with the values that our code provides. It's really the thing that's actually running the web application or the website that we're building. And like I said, obviously we would like to choose a framework that sets us up for performance success. But how do we know which framework to choose? Well, the lucky thing for us is that we are really spoiled for choice when it comes to frameworks. Frameworks come in all flavors and in all shapes. You can get triangle frameworks and rectangle frameworks and whatnot. It's really great that we have so much choice around frameworks. But again, which framework should we choose? And the answer is that we should measure, because really that's the only way in which we can really know which framework is the best in terms of performance. Now, there are two ways in which we can measure performance of the frameworks. One way is known as lab tests. In a lab test, what we do is we create a synthetic environment, and then we test whatever you want to test in that environment. Now, this has two main benefits. The first benefit is that it's a totally controlled environment. We can test exactly what we want to test and measure exactly what we want and need to measure. The second advantage is that it's totally reproducible. If we get a certain result and we want to share it with our colleagues, no problem. They can, run the exact same test in the same lab environment and get the exact same results. But there's also a problem with the lab tests. First of all, it's a lot of work, and nobody likes to do a lot of work, like creating the lab environment. And it's especially a lot of work when we're thinking about lab testing frameworks, because it means that we will effectively need to build the exact same web applications using all of the frameworks in order to test and compare them. And like I said, that's a lot of work. And also, there's a question of which tests do we want to build? How do we know exactly what our users are experiencing, what their environment is? It's very easy to accidentally test a scenario that's actually different than what our users are really experiencing. And therefore, we have an alternative approach, which I prefer whenever I can use it, which is to use field data. That means collecting real user measurements from the field and using these real user measurements, or RUM for short, as the input source or the data source for our comparison. But there's a problem here, because if you think about it, in order to get real user measurements for all the sessions, for all the websites, using all the frameworks, we effectively need to instrument all this code to collect the performance data. And obviously, that's not something that we ourselves can do. But there is somebody who can do it, or close enough. And that someone is Google. Because it turns out that Google actually instrumented the Chrome web browser to collect performance data for all sessions of all users, unless you effectively opt out, and then upload it into the Google Cloud, into something called the Chrome User Experience Report database. Now, Google uses this data as a ranking signal for their search engine, but they also provide us with access to this data, and I will show how we can get to it in a minute. But which data do they actually collect? Well, they collect a whole bunch of data, actually. But from our perspective, from our focus on performance, we're really interested in these three. These are the core web vitals, or the current core web vitals, and there are three of them. There's largest contentful paint, or LCP, which we will show what it measures in a second. There's first input delay, or FID, and there's cumulative layout shift, or CLS. And for each one of them, we can see that there are ranges. If the numbers are in a certain range, they're considered good or green. If they're in a higher range, they're considered yellow or need improvement. And finally, if you exceed the final range, you get into the poor or red zone, and you really need to up your game. And a site is considered to have good performance if, for 75% of all sessions, they're in the good range for all three metrics. Now, this sounds a bit harsh, but it really isn't. Because if 25% of your users, if more than 25% of your users are getting a poor or needs improvement value for one of these metrics, again, it means that too many users aren't getting the performance that you would like them to get. So now let's go quickly in more detail into these metrics so that we know what we're measuring before we dive into how the frameworks stack up in this regard. So as I mentioned, the first metric is LCP, or largest contentful paint, and what it measures is the time that it takes for the largest piece of content on the page in the initial viewport to render. So it's a measurement of time from the start of the session, which is the navigation start, which is literally when the user clicked the button to get to your website, or the link to get to your website, until the largest piece of content is shown. Now, what is the largest piece of content? I mean, it varies over time, and that's exactly the case. Let's say that we're looking at this site, which is an old version of CNN. And by the way, CNN has pretty abysmal performance rankings. So we can see that as the page starts to load, the first piece of content is that bit of text on the top left. And that's the initial candidate for LCP. So if the session were to stop there, that would have been the LCP. But more content continues to load. And we see that every time more content loads, the browser updates, as if relevant, the candidate for the largest contentful paint. So in the second frame, you have a new candidate. It remains the candidate on the third and fourth frame because nothing larger was rendered. But then on the fifth frame, finally, an even larger piece of content, that image, was rendered, and that becomes the final LCP candidate. And at that time, when that image was shown, that's the value of the LCP. And we can also see here that LCP can be text and images. Cumulative layout shift measures how much the content on a page moves around, not in response to direct user interaction, but on its own. Think about, I'm sure you've experienced some news site or some content site that you're reading the content and suddenly it loads some advertisement and the content moves around and you lose your place, and that's very annoying. So Google is trying to fight against that with this metric. This is not a metric of time. This is a metric, a unitless metric that essentially measures how much the content shifts around. And we can see how it works in this example. You see that initially the button wasn't there, and then the button appeared. Now, when the button appeared, approximately half of the page shifted down. That's all the green area. And the amount that it shifted was by 14% of the initial viewport. So the shift score, or actually penalty, for this particular layout shift is 0.5 times 0.14, which is 0.07, and it accumulates these values. It does it in a sort of a this kind of bursts or batches, but I'm not going to go into that. But effectively, the largest shifts that occur in the page during the session, that's the CLS score. And finally, we've got FID, or first input delay, which measures the amount of time it takes to the browser to be able to respond to the first and only the first interaction on the page. And it measures the time from the actual interaction until the browser is able to actually respond to it and is not blocked by something else, like, let's say, long-running JavaScript. Now, how can we get at this data? Well, it turns out, like I said, Google uses this data for its own needs as a ranking signal for the search engine, but it also exposes this data to us. So if you go into, for example, the Google Search Console, you can see how many of your pages and which pages get good scores or poor scores or need improvement. And it all comes from the same database. Likewise, if you've ever looked at the Google PageSpeed Insight service, which is built on top of Lighthouse, so it actually does two things. It uses Lighthouse to run a synthetic test, but it also at the actual top, because that's the more relevant and important information, it actually gets data for that URL that you provided from that Crux database and exposes this to you. And another example, even third-party tools, or you yourself can access this data. So this is a screenshot from the Web Page Test website. And again, Web Page Test is a great tool, not created by Google, but it still is able to access this data from the Google database and show it to you for the page that you're testing. And like I said, you can also get at this data yourself. But it's really great that we can get at the data for a particular page, but that's not what we want. We want to get the data, the aggregated data, for all the pages that use a particular framework. How can we know that? Well, it turns out that the Google Crux actually has some friends that help with that, because whenever Google uploads data for a particular URL, it also runs web page test on that URL and gets that data as well, and some other things, and puts this data into the HTTP archive, which is a sister database to the Crux database. So when you run queries, you can actually get data from both and correlate them. And one of the things, additional things that they do is that they actually use a tool called Webalizer to actually analyze which libraries and frameworks are used in the page, and this way they can determine and assign in the database for the URL for example, the framework that it uses, so that we can actually do a query on all the pages that use a particular framework, or all the sites that use a particular framework, and then get the performance scores for all these sites. Now, like I said, we can do this query ourselves, but we don't have to, thanks to this guy. This is Rick Viscomi, who works at Google. He's an engineer that actually does a lot of work around the Crux database, and he built this excellent tool that they're actually in the process of updating right now. So maybe by the time you get home and try to use it, you might see a different UI, but I think it'll take him some more time. But anyway, what he did is he actually built this tool that does the queries for you and shows them in a graph, so you can graph the performance of websites that use particular technologies. So you can see the ratio of websites using a particular technology that pass Core Web Vitals. That means that they get the all green at the 75th percentile. So for example, if you see here a score of 50%, it means that half the sites built using this technology pass Core Web Vitals and half do not. Now, before we go on, I need to remind everybody that correlation and causation are not the same thing. And you need to be really careful with how you use this data and not to mix up cause and effect, and be careful like what might influence this data. And we will see some examples of this later on. But even given that, I don't want to go back to Internet Explorer, and I'm guessing that you don't want to go there either. So let's start. This is how the graph looks like if we look just at two things. The darker blue line is all, which means it's for all the websites in the Crux database. And this just shows us how difficult it is to build a website with good performance, because what we can see is that effectively 2/3 of websites don't have good performance. Only 40% of websites actually have good performance. Now, the lighter blue line is WordPress. I put WordPress there because WordPress, first of all, it's an interesting line to compare with. Like, do the websites that we build with using frameworks, do they have better or worse performance than WordPress? I mean, something is pulling the dark blue line above WordPress. Is it the frameworks? We will see. It's also worth remembering that WordPress is 1/3 of all websites, and this is much more than all frameworks put together. Okay, so remember that. Don't be too cocky. Also, I want you to notice that I'm looking at data for mobile. This tool actually is able to show data for either mobile or desktop. I'll be focusing on mobile throughout this presentation. First of all, just to cut down on the number of slides, but also because we live in a mobile-first world. Most of our sessions are on mobile, and usually getting good performance on mobile is more challenging than it is on desktop. Okay, so finally we got there. This is the data for the top framework, and this is not a value judgment or anything. I was just looking at the top frameworks in terms of number of websites built using them. So if your favorite framework is not there, don't worry, we'll get to it. But again, it just means that it has fewer websites built using it. And here we see the usual suspects. I kept WordPress on there, and also the all-line. React is the most popular framework. It has approximately the amount of websites as all the other frameworks put together. Vue is also pretty popular. Preact is up there, and also Angular. And here we can finally see the results and the scores. And what do we see? We see that React and Preact are actually better than WordPress, but they're still below the average for the website, for the web as a whole. So it's not really them who are lifting that darker blue line. It's websites you built using some older technologies, probably. We also see that Angular is pretty abysmal, and that Vue is a bit lower than React and Preact. And does that mean that React is better for performance than Vue? We will see. It seems to be, but like I said, be careful of mixing correlation and causation. Now let's look at more frameworks. This time I'm looking at leading frameworks, any framework that effectively had kind of, let's say, enough data to actually have meaningful lines, more or less. We can see that, so I didn't mention it. You notice the interesting hump in the Preact data, that yellow-orange line. It doesn't mean that Preact started really good and then got worse. It's just that Preact was not properly recognized by Wapalizer before November 2021. So all the data before that date is just wrong. It's still there, but it's wrong. So that's another example of where we need to be careful with the data. And another example is the data for Quick. Quick seems to be all over the place. It's got really good, and then it got really bad, and then it got really good again. And that's not the case. The problem is that there are very few sites built using Quick. In fact, you can more or less measure them on two hands, which means that you add a website. If it's good, the score goes up. If it's bad, the score goes down. So, it will take some time before the data kind of steadies itself. Now, you might notice something that might surprise you. We know that Svelte and Solid, and we've got Ryan here, are really great for building performant websites. Yet, according to this graph, they seem to be doing worse than React. Is this really the case? Well, we need to remember that this data is for people using websites all over the world. And the quality of the network in different countries can vary a lot, and also the quality of devices. In the UK, the vast majority of mobile devices are iPhones. But if you go to a place like India or Brazil, the vast majority are low-end Android devices. And likewise, the networks are not as good. Now, if you think about it, people are more likely to use lighter weight frameworks in places where, such places where devices and the network aren't great, and that will actually penalize those frameworks. So luckily, we can overcome that by using a filter in this tool, and that's looking only at website sessions in the US. And we can see that all of a sudden the scores for Solid and for Svelte have jumped up and are now either equal to React or even slightly better. And again, we need to take into account, though, on the other hand, that now we've cut the number of websites even lower. So in the case of Solid, for example, we're talking, again, under 10 websites currently in the database. Hopefully, you people go out there and build more websites using Solid. It's an excellent framework. But Quick is doing really well, but again, I think it's like 9 websites, something like that. So it's really low numbers. But we see that Angular remains really low. Now, it's interesting. Another interesting thing that we can do, another interesting filter, is not to look at all the websites, but to look at the top websites in terms of traffic. So here, I'm looking at the top 100K websites in the US, and I had to drop some of the frameworks because they effectively had zero, close to zero websites in this category. And we see something interesting. We see that the scores really moved around. Some scores went up, some scores went down. Now, initially, I expected all the scores to go up because my assumption was that, you know, the top websites can afford to hire the top engineers, they can afford the top infrastructure, use the best CDNs. Also, the CDNs will always be hot because there would be a lot of traffic to the websites. But turns out that that's not always the case. Now, I don't expect you to remember the previous numbers, so let's compare them side by side. And what we can see is that, as expected, WordPress did go up apparently for the reasons that I listed, or I assume so, by a significant amount. Angular is also up by a lot, by 30%, but it's up from 14 to 18. You know, it's pretty abysmal still. So yeah. Svelte is actually down by 9%, which is surprising, and I don't really have a reason for it. So if anybody is interested in an interesting research project, is to try to figure out why this is. Vue and Preact remain essentially the same. So it means that effectively it seems to mean that with Vue, you know, whether you're a Vue beginner or Vue expert, you're likely to get more or less the same performance, which is both good and bad, I guess. But the really interesting one is React, which is down by 16%, which seems to indicate that the better you get at React development, the worse website you'll create. And that really surprised me to the extent that I researched it, and I think I figured out the reason why we get this surprising behavior, and we'll get to that in a minute. So let's look at the leading meta-frameworks, for example. You know, we have the frameworks, but on top of them, we have the leading meta-frameworks. And as we can see, most of the leading meta-frameworks, not all of them, but most of them, actually raise the score a little bit. So before we were in the 30s and 40s range, now we're in the 50s to 60s range. And that's not really surprising because meta-frameworks introduce server-side rendering or static site generation, which are great ways to improve performance because, for example, without static site generation or server-side rendering, SSR, you're not going to get a good LCP score. So your LCP is probably going to be bad if you just do client-side rendering. So, and meta-frameworks really help by providing the ability to do SSR and SSG. Now, let's focus. Oh, one more thing. We see that Astro really has great numbers. Again, not surprising. Astro, unlike effectively most of the other meta-frameworks, does MPA, or multi-page application, rather than single-page application. Now, currently, Crux only really measures for single-page applications the initial load. It doesn't measure the subsequent load as actual page transitions. So it kind of penalizes SPAs in this regard, because if you think about it, with SPAs, we are paying a higher initial price for the fact that we have better experience down the line. With Astro being an MPA, every Astro page that you load is another navigation, which gives it two benefits. It can load less upfront, and a lot of things are cached for the subsequent navigations, so it actually improves its score. But you know, you lose all the benefits that you get with single-page applications. Now let's look at React meta-frameworks. And this, I did this in order to try to figure out that surprising behavior that we saw with React actually going down for the higher traffic websites. Now, we look at what we might expect to see here. We are seeing Next.js and Gatsby and Remix, but you might be surprised to see Wix here. Why am I listing Wix as a React Meta framework? So for those of you who don't know, Wix is a drag-and-drop website builder. They're now also a development platform. By the way, full disclosure, I used to work there before I worked at Next Insurance. And the reason that I'm listing Wix here is because Wix is actually built on top of React, which means that every website that is a Wix website, it will be identified by Crux both as a Wix website, but also as a React website. So Wix definitely impacts React scores overall. And as we can see, Wix actually has significantly better performance than all of the React Meta frameworks. Now think what that means. It means that somebody building a website using drag and drop is more likely to produce a fast-loading website than a top React developer using the latest and greatest frameworks, say Next.js or Remix. That's not where we, as web developers, I think, want to be. But what's the impact that Wix has on React score overall? Well, for that, we can also look at the number of websites built using those various frameworks. And as we can see, Wix websites by far outnumber all the websites built with the various frameworks. Now, Next is making really good progress. Their line is going up at a rapid clip. But still, almost a quarter of all React websites in the world are actually Wix websites. That was surprising to me, even as somebody who worked at Wix. So yeah. And with the closest one, which is Next.js, that's only about 10% of all React websites. All the rest, I assume, are just client-side rendered. Now, if I filter for the top 100K, Wix goes almost to 0. And that's not surprising, because Wix focuses on small and medium businesses. On the other hand, now Next.js is effectively almost a quarter. So that explains to me what happened with React, why we saw React having better numbers in the in general than when we look just at the top websites. Because when we were looking at all React websites, Wix actually lifted the React scores. Whereas when we look at just the top 100K, the frameworks, Next.js and the client-side rendered React websites are actually pulling the scores down. So it's not that we are doing a good job in terms of performance as React developers, is that Wix is kind of gaming the scores for React and pushing it up higher than it should be. And again, indeed, if we look just at React and Wix and Next.js, we can see how Next.js is kind of pulling the scores down, and Wix is kind of pulling the score up. Now, to be fair, Wix has something of an unfair advantage or advantages here. First of all, Wix can afford to hire and employ the top web developers and top engineers in terms of React performance, because it's like a group of, 100 people working on effectively on millions and millions of websites. They can also afford to use the best CDNs. And probably one of the most important advantages that they have is because it's an online service, it's automatically updated whenever they come up with a new version. So whenever Wix deploys a change, and by the way, Wix deploys a change once every 2 minutes, more or less. So whenever they deploy a change to production, all Wix websites automatically get it. On the other hand, when we're looking at a framework like Next.js, there's a huge long tail. For example, at Next Insurance, we use Next.js for our public website. And by the way, we have good performance. And we are still using version 12. We haven't upgraded to version 13. We are looking at React Server components, but we will probably not start implementing it or even working on it seriously for a good 6 to 12 months, because it's just not a top priority for us now, and it feels really rather new and not yet totally stable, and the mutation story is not done yet. So we really wanted to stabilize and see the best practices before we get in there. And I assume that there are a lot of projects out there like that, projects that are still using older versions of Next.js, which means that even when Next.js improves things, and they are definitely working on improving things, like, again, the work that they're doing with React Server components, all the work that they've done around image optimizations, all of these things really improve performance, but it can take a long time until they actually make it out to the field and actually have an impact on real websites that are out there. So this is, again, something that you need to remember, that when you're looking at a certain framework, how much of it is the long tail. For example, with Angular, I assume the long tail is huge, versus how many of the websites are actually really new. If you're looking at Quick, all the websites have been effectively built, in the past couple of months. And another thing, by the way, talking about Quick, is that you need to think about is that anybody who's using Quick is a developer who's really interested in web performance to begin with. So they are likely to be paying attention much more to all the various optimizations that they can achieve. So again, especially when you're looking at the newer frameworks with the lower numbers, you need to take that into account, that they're getting a boost just from the fact that they're on the bleeding edge in terms of performance. One more thing that I need to mention. So we talked about the 3 core web vitals, and one of them was first input delay, which, as I said, oh, this is cool. I don't see any ghosts here, though. Oh, those were the ghosts. Okay. Okay. So this is the first input delay. And the first input delay, like I said, measures the time from when the user interacted with the page for the first time until the page can actually respond to that interaction. Not the response itself, but can respond. Now, this metric has effectively done its work. If you look at all the frameworks, even the ones that we know overall aren't getting good performance scores, effectively all of them have good FID scores. So you can say that FID is 1, and it's done its job, and it's time that we move on. And indeed, that's what's happening. At Google I/O, which happened just about a month ago, something like that, a few weeks ago, Google announced that they're going to be replacing FID with a new metric. And the metric that they're going to be replacing with on March 2024 is called INP. It was actually available out there for a while now as an experimental metric, and they've been fine-tuning it and waiting to see that how people are responding to it and soliciting responses. We discussed it, for example, at the Web Performance Working Group, and it's really different because it has 2 main changes compared to FID. First of all, it doesn't look just at the first interaction, it looks at all the interactions and effectively looks at what is the worst interaction but excluding extreme outliers. So really, out of the normal interactions, it looks at the worst interaction, not just the first one. And the second thing, it doesn't just measure the time from the interaction until when it can process the interaction, but it actually measures the time from the interaction until the next paint that results from the interaction. So it measures the processing time of the interaction itself and even the browser's rendering update. So that's why they extended the good time from the limit from 100 milliseconds to 200 milliseconds. But it's much more challenging to get a good INP score than it is to get a good score for first input delay. How much more challenging? This much more challenging. So if before all the frameworks were at effectively 100, when we look at INP, we see that they are 60, 70. Again, Astro has this benefit of hardly doing hydration. Quick, with all the tricks that it does, also gets pretty good scores. But again, reminder, really small number of sites. For the others, they're in the 60s. For Next.js, it's even worse. Again, I'm really hoping that React Server Components is able to lift Next.js up. But what this means is that when Google switches in, what is it, less than a year, it's about 10, 8, 9 months, something like that, to this new metric, expect all the scores to go down by something like 20 to 30%. So if you think the scores are bad now, they're going to get a lot worse. And that's definitely a wake-up call for all of us as web developers. So, to sum things up, first of all, we saw that Crux is a great source of information, and I highly recommend using it. It also has some limitations, especially if you're looking just at your particular website. For example, it goes on a 28-day moving average. So when you make an improvement, it can take a couple of weeks to actually show up in Crux. So for if you're looking at just one website, this is not necessarily the best tool in the world. You might want to look at one of the third-party RUM providers that are out there. But if you want to look at all the websites in general, Crux is an amazing resource. And again, you can use either the existing tools or you can actually run queries directly on the data itself using BigQuery and the available APIs, like Web Page Test does. The second thing I want to mention is that if we looked at the numbers, none of the frameworks got a 0 score, which means that you can build a fast working website using any framework, even Angular. Likewise, none of the websites got a perfect 100 score, which means you can build a slow website using any framework, even quick. So, you know, that's something important to take into account. That said, the difference that we saw in ratios was pretty significant. And as I said before, while correlation and causation are not identical and you need to take into account the other factors, like whether it's new, whether it's old, how long is the long tail, how many people are actually using it, and so forth, at the end of the day, if all other things being equal, if I need to choose between frameworks, I would prefer the framework that is more likely to help me build a fast website. And I assume that I myself, as a web developer, am not that much different from all the other web developers in the world, so that if almost everybody is building a slow website using a particular framework, I'll be the exception and build a fast one. We saw that even the top frameworks, again, top in terms of performance, number of websites built using them, have worse performance than the web in general, which is not where we expect to be. Web frameworks are supposed to help us build better websites, not worse websites. And if you're slower, that definitely means that you're worse. And even more significantly, we saw that the top frameworks have dramatically worse scores than Wix. And again, your neighbor who knows nothing about web development and just wants a website for his business, uses drag and drop, builds a website, his website will be faster, probably, than the website that you will build for him using React or Vue or whatever. And again, that's not where we want to be. And as I said, the situation is actually going to get much worse when Google switches from FID to INP. So to sum things up, we took the analogy of the framework as the driver. Well, in terms of performance, it's driving us into a wall. I'm really hopeful about the new frameworks coming out like Solid, like Quick, and Svelte, and so forth. But, the proof of the pudding will be in the eating, and we will really need to see that as we transition to these frameworks or new features of existing frameworks, like React Server Components, that our scores start going up. And with that, I conclude my talk. So thank you very much.